today we are going to start the next topic, which is titration, right? So let's see what we have studied till now. Then we will move to the next topic, which is titration. Now, before moving to this topic, before moving to titration, let's recall what we have studied till now, right? So if we recall the concept that we have studied till now, right? Just think about this, right? The first concept that we have studied is basics of reaction. What is redox reaction, right? What is redox reaction? Okay. So in this we study what is oxidation, and then we study what is reduction, then we study the concept of oxidizing agent, reducing agent. Are you not able to hear me? My voice is low.
Okay, sorry. It was connected to Bluetooth, that's why. What about now? Is it audible? Is it fine now?
Clear.
Clear? Okay, just give me 1 minute. Okay, now, and I'm not muting anyone, so please, if you have a, yeah, it's fine, right? Very good. Okay. So we studied the basics. Let's recall what we have studied, because whatever we have studied in this chapter is for this topic, titration. Okay, we will be using everything for this. Okay, then we studied what is oxidizing agent and what is reducing agent. Oxidizing agent and reducing agent. Right? We studied about oxidation number. Right? Then we studied about balancing of redox reaction. After that, we studied concept of equivalent or equivalent concept. Okay, in this we studied the concept of equivalent, right, or gram equivalent. Okay, then we study what is normality, what is valency factor, okay, and after that we studied law of chemical equivalence. Law of chemical equivalence. Right, right, everyone. So this is, I can say, the topics that we have covered till now. Just raise your hand if you remember, right? So I'm not talking about the subtopics. It is the main topics that we have covered. Why? Because we will be using all these for titration. Okay. Yes, Karishma, we will start with law of chemical equivalence only. Don't worry. Okay, because we haven't solved many problems on the law of chemical equivalence, right? So we will solve some problems based on that. Okay. Now, what is law of chemical equivalence? I'll repeat it once again. Law of chemical equivalence. Law of chemical equivalence, or law of equivalence. Okay. Now, if you remember the mole concept, we have principle of atomic conservation, right? Now, as I told you that this equivalent concept is something similar to mole concept. Okay, so this comes under the part of volumetric analysis, right? Now, suppose I'm having a reaction. Just write the reaction. AA plus BB gives Cc plus Dd, right? Okay, this is my reaction. Now, if you remember the mole concept, so according to mole concept, okay, we use principle of atomic conservation, right? Which means moles of A divided by stoichiometric coefficient A should be equal to moles of B divided by stoichiometric coefficient B is equal to moles of C by stoichiometric coefficient C is equal to moles of D by stoichiometric coefficient D. Right, everyone? Right? Okay. Now, what is law of chemical equivalence? So, according to equivalent concept, we say that we modify this statement and we say that, okay, either you write equivalent or milli-equivalent, right? So I'll be writing milli-equivalent. Milli-equivalent of A should react with, right? One milli-equivalent of A, right? Milli-equivalent of A should be equal to milli-equivalent of B, should be equal to milli-equivalent of C, and should be equal to milli-equivalent of D. Okay, right, everyone? Right? Now, I told you that these two statements are actually same. How? Now see this. We know that equivalent is equal to, tell me what equivalent is? Moles into valency factor. Got it? Yes or no? Moles into valency factor. Okay, so we'll be using these two. To solve the problems, right? Okay, we can use either of the concept to solve any problem. Now, to use the concept of mole, right? Mole concept, we should have balanced equation, right? Balanced equation, but equivalent concept can be used even for unbalanced equations. Okay, right? So that's one benefit. You don't have to balance the equation. Okay, now let's see some examples, right? We have solved only one example in last class. So let's see one example. Suppose I'm having a reaction. Okay, or it is asked to find, question is find number of moles of KMnO4 needed or required to oxidize 2 mole of CO2s in acidic medium. In acidic medium. Now, as I told you, right? In order to solve any equation, right? First of all, you should know what is happening, right? What is the equation? Now, see this. KMnO4 is acting as an oxidizing agent, right? And in acidic medium, that's what I have told you. You should remember that what happens. You should remember some equations, right? I'll just send that equation to the group itself. But we know that if KMnO4, wait, is acting as an oxidizing agent in acidic medium, then KMnO4 is converted into, so, and it is Cu2s, is converted into Mn2 plus, right, everyone? Right? And obviously Cu2 plus is, tell me, oxidized, right? So, okay, here if you see the power, it is +1. So it is oxidized, means it is losing electrons. So it will become Cu2 plus. Got it? Plus SO2. So SO2, even if you don't know SO2, it's fine. But this is the reaction, right, everyone? This is the reaction. Now, according to law of chemical equivalence, what we can say here? We can say that milli equivalent of KMnO4. See, this reaction is not balanced, right? You don't have to balance this. You don't have to balance this if you know the law of chemical equivalence. So we will just do this. Milli equivalence of KMnO4 is equal to milli equivalent of Cu2s, right? Now, what is the benefit here? The benefit is you don't have to worry about SO2, Cu, right? You just have to worry about these two. And you don't even have to worry about the stoichiometric coefficients, right? You just have to see that what is the N factor, what is the valency factor. Now, we know that milli equivalent is basically what? Millimoles of KMnO4 into valency factor. So I will just write as N1 is equal to, this is also written as millimoles of Cu2s into N2, right? Now, millimoles can be written as moles, doesn't matter because milli will get cancelled, right? So I'll just write it as moles, okay, of KMnO4 into N1 is equal to moles of Cu2s into N2. Everyone getting this concept? Tell me, everyone is getting concept till this point? Just raise your hand, right? So what do you need to know for this reaction? What do you need to know? Tell me. Tell me everyone, message or you can speak. It's better to message because others won't know. Okay, so they can also think. What do we need for this reaction? We don't need to balance, right? But what else do we need? Tell me. Valency factor, yes, right? We need valency factor. Okay, valency factor. So we need to find valency factor of KMnO4, right? So think about this. Valency factor of KMnO4 is what? Tell me. We already know this. In acidic medium, it is converted from, okay, it is converted from +7 to +2. So valency factor of KMnO4 is 5, right? Yes or no? Yes or no? Right, everyone? Right? Now, what is the valency factor of Cu2s? Tell me. So this is N1. This is N1. What is valency factor of Cu2s? We have solved this already. Valency factor of Cu2s. We have already solved it. Tell me. Anyone? Valency factor of Cu2s? Someone asked me also regarding that what can be the maximum valency factor? See, valency factor is not same as oxidation number. You should remember. Now, if you see this, yes, very good, Anamika, very good, right? Very good. It is 8. Very good, everyone. So if you see this, Cu2s, in Cu2s, we have two entities, Cu and S. Now, Cu is changing from +1 to +2, right? And 2 Cu is changing. So 2 electron is exchanged. 2 electron is exchanged. Now, S is changing from +2, sorry, -2, my bad. -2 to, tell me, +4. Okay, -2 to +4. So this is also giving 6 electrons, losing 6 electrons, right? Okay, so plus 6 electrons. So Cu is losing 2 electrons and S is losing 6 electrons, right? So total how many electrons is lost? 8 electrons is lost, right? So for Cu2s, the valence factor is 8. Got it, everyone? Tell me. Got it? We have also this example. Tell me yes or no, right? Because in Cu2s, both Cu and S is changing the oxidation number, right? Okay. So now see this. So I can see that mole of cheminophore, we don't know. We write it as X into valency factor of cheminophore 5 is equal to moles of Cu2s. I have given it as 2 into valency factor of Cu2s is 8. Now, can't you find X? X is equal to 16 by 5. Got it? Easy? Tell me, easy? Yes or no? Got it, everyone? Kashma, got it? Yes. Now you understood the concept of equivalence, law of chemical equivalence. So if I ask you which is the most important concept, right, in order to solve this problem, right, you should know how to find the valency factor, right? Right, everyone? So let's solve one more example. Okay, let's solve one more example. And most of the reactions you have to remember, okay, that what is happening in acidic medium or in basic medium. So these are not just questions, these are the concepts. Okay, because these reactants, these compounds will be used everywhere. Cu2s, cheminophore, oxalate, H2O2. So I'll give you the list, don't worry. Now let's see second question. Okay, again the easy one. The question is, the number of moles of oxalate, okay, ion oxidized by 1 mole of aminophore minus, okay, aminophore minus in acidic medium. In acidic medium. Tell me everyone. So you can just write, now you can just write the main statement, which is number of moles of oxalate, right? Moles of oxalate, okay, into valency factor of oxalate is equal to moles of aminophore minus, wait, into valency factor, right? Tell me, can you write this directly? Now, I hope all of you know what is oxalate. It is C2O4 2 minus, right? So see, I hope all of you remember this. We have done this. C2O4 2 minus is converted into what? C2O4 2 minus is converted into what? CO2. So if you see, the charge here was +3. It is converting into +4, right? Right, everyone? So valency factor, this thing you have to remember, okay? Otherwise you can't solve it. Of C2O4 2 minus. Now, if you don't remember, you can just think intuitively, right? Because C2O4 +3, right? +3, it is getting oxidized. So obviously it will lose electron, and C, right? After losing 1 electron, it can form Cu plus only. So it can lose only 1 electron, right? But here it is C2. So 1 mole of C2O4 gives 2 mole of electron, right? So the valency factor of C2 is 2. In the same way, we know the valency factor of MnO4 minus. We already know that. Of in acidic medium it is 5. Now tell me what is the answer. Tell me guys, what is the answer? Isn't it easy? Yes, very good Anisha, right? So this is, yes, x into 2 is equal to 1 into 5. So x is equal to 5 by 2. Got it, guys? Got it? Very good, Anamika. Very good, Soumya Lakshmi. Got it? Okay. So let's solve one more problem. Okay. Let's solve one more problem. Okay. So these are the quite straightforward questions. These are quite straightforward questions. Now, what if I use the concept of molarity? Yes, 2.5 Karishma. What if I use the concept of molarity, right, in that? So instead of giving number of moles, I will give molarity and volume. Okay, so this question is like this. What volume of, what volume of 6 molar HCl? 6 molar HCl, right? And 2 molar, 2 molar HCl should be mixed. This is simply based on mole concept. Okay, this is simply based on mole concept. You don't have to use the concept of normality here, right? But I'll tell you why I'm using this to get two liter of 3 molar HCl. Now, tell me what we have to use. Tell me, guys. We have to use mole concept over here, right? Because everything is given this. So what we have to use? Think about it and tell me the answer. This is the prerequisite of mole concept because we'll be using the same concept. So I hope all of you remember the number of moles will be same, right? The number of moles. So can I say that N1 plus N2 should be equal to N3? Number of moles should be same, right? Yes or no? Right, guys? So what is N1? N1 is M1 into V1 plus N2 is M2 into V2 and N3 is M3 into V3. Now it is given that V3 is equal to 2 given. V1, if we take it as X, so what would be V2? The sum of these two is equal to 2, na? So V2 should be 2 minus X. Now, can't you find it? Right? It is a linear equation on one variable. Yes. So it will be 6 into X plus 2 into 2 minus X will give you 3 into 2. So you can solve this and get the value of X. Right? Right, everyone? Yes, 0.5 liter and 1.5 liter. Very good. Got it? Okay, very good. Very good, everyone. So I guess all of you got the basic idea. Okay, very good. Now, what do you think? If the reaction is balanced, if the reaction is balanced, which method is better? The mole concept or concept of equivalent? Tell me. Tell me, guys. Yes, for balance, mole concept is much better, right? Now, why mole concept is better? Because if you observe, the valency factor of the same compound is varying, right, everyone? The valency factor of the same compound changes. It depends on the reaction, right? Right? For example, KMnO4, right? KMnO4 in acidic medium valency factor is something, right? In basic medium valency factor is something. So the valency factor changes according to the reaction. So I can say that the equivalent weight of any compound changes depending on the reaction, right? That's why if we have balanced reaction, mole concept is better. Okay. Now that's one thing which I'm telling you. If you have remembered the reactions, if you know the reactions, for example, what is happening in acidic medium, what is happening in basic medium, and if you know the valency factor, then use chemical equivalent concept. If you don't know that, right, it will take with time, but balance the reaction, use mole concept, right? So it's not that if you don't remember, if you don't know the valency factor, you cannot solve it. You can solve it, right, using mole concept. Any problem that can be solved by equivalent concept can be solved using mole concept. Okay, that's why I said it is your parallel concept. Okay, right? Okay, let's solve some more examples. Let's solve some more examples. Because if you talk about the concept, it is same as bone concept. Concept is very small. You just have to use, right? You should know how to use it. Okay. Now, there's a word called titration. Okay. So first, what is the meaning of this word titration, right? So as I told you, right, the word titration means kind of neutralization, because there are many type of uh, titrations, right? So I'm talking about redox titration. So redox titration or acid-base titration. So acid-base titration is actually your neutralization reaction. Okay, that's why I'm trying to explain you for the concept of acid-base titration. Okay, there are different type of titration. The name is given. Now, focus on acid-base titration because the concept is same. Now, if we talk about acid-base titration, what happens in acid-base reaction? What happens in acid-base neutralization reaction? Tell me. Tell me, guys. Acid react with base, they neutralize each other, right? They neutralize each other. Yes or no? And at one point, I'm talking about strong acid, strong base. Okay, right? I'm just assuming that reaction is going to complete. Now, at one point, the neutralization reaction stops. Agree, right? Or I can say that at that point, the solution is neutralized. Yes or no? Think about it. Yes or no? Right? So that process is called as acid-base titration. If you have, like, if you will do this experiment, I'll show you the videos. I'll just send you the videos of these experiments, because this topic, right? This topic is widely used in for experiments in your laboratory. So I'll just send the videos that you can see. But if you have observed, right? So whenever we take a wait, I'll just show you a video, right? In this video, I'll be showing you how you can perform titration. Titration. Now, titration is useful when you are making a solution that you don't know the polarity of it. By performing titration, you get to know the concentration of this solution. So how can we do this? We will be using a titrant. A titrant usually it's a solution that we know everything about, which means that we know sodium hydroxide and also we know the molality of it. Now this titrant, you fill it with a burette. So the titrant goes to the burette. Now the solution is called analyte, and the analyte we added to that analyte flask. Now, in order to start the titration, you need to take a known volume of your analyte. So I will be taking 10 milliliters with a volumetric pipette. So this is going to give me a very accurate volume. Yes, I'll share the link, right? Is it not clear, everyone? Is it not clear? Tell me. Okay, so I'll do that. I'll just send the video, right? I'll just send the video. Okay, I'll okay, okay, Sania, I'll just send the video. Don't worry. Okay, yeah. Thank you, Samarth. Right. So we have titrant, titrate, and indicator. Okay, right. So what is titrant? Titrant is the compound. Titrant is the compound whose concentration we already know. Okay, whose concentration we already know. Right, everyone? And what is titrate? Titrate is basically the compound, right, whose concentration we want to know. Okay, an indicator. So indicator is basically a substance which will show you the change, right? Okay, which will show you the change when the reaction is completed. Okay, right? Okay, everyone, got it? Tell me. I'm just trying to be very simple, right? I'm just trying to keep it as simple as possible because titration is a very big topic. Okay, so if I teach you starting from the hi-fi things, it will be confusing and you might get scared. So I'm just letting you know the basics, very basics of titration. Okay, so we'll try to learn this with examples only so that it will be better. Okay, because what is titration? Titration is nothing but the application of law of chemical equivalence. Okay, yes, Soumya. Titrant are basically the compound whose concentration we know. Okay, right, whose concentration we already know, and titrate is the compound whose concentration we want to find. Okay, now let's see one problem, right? Let's see one problem. Okay, so this is simple titration. Simple titration. Now, even if I don't mention the word titration, right? Even if I don't mention the word titration, you can solve the problem. Okay. Now think about this. The question is this. Question is this. 0.4 molar KMnO4. 0.4 molar KMnO4 solution, right, reacts completely with 0.05, reacts completely with 0.04 molar FeSO4. Okay, right, under acidic condition. Under acidic condition. Okay, got it? So the question is, if volume of FeSO4 is 50 milliliter, 50 milliliter, find volume of KMnO4. Now tell me, can you solve this without using any concept of titration? Can you solve this? Tell me. Tell me, guys, what is the answer? Anyone? Okay, Nishita, very good. 400 milliliter, okay. Now see this, the concept here, will you use this M1V1 is equal to M2V2, or you will use N1V1 is equal to N2V2? Tell me, you will use this or this? Tell me guys, you will use this one or this one? This is mole concept and this is equivalent concept, right? Because N1 is basically gram equivalent, na? This is gram equivalent, right? Mole concept or equivalent concept? See, you can use both, but since we don't know the reaction, we don't want to find the reaction, we don't want to write the reaction, right? Okay, you should use this concept, okay, equivalent concept instead of mole concept. That's what I'm saying, right? So, and we know that normality is equal to what? Normality is equal to molarity into n factor. Yes or no? Right? Okay, right? Normality is molarity into n factor. So this statement can be written as m1 n1 v1 is equal to m2 n2 v2. Got it? So you cannot use this because the reaction is not balanced. Got it? Right? Not balanced. Yes or no, guys? Tell me, yes or no? Got it? Got the concept? Right? So you should not use m1 is equal to m2 v2 just because m or v is given. Okay, right? So you should use this because normality is molarity into n factor. Now, n factor of KMnO4 we know already. So 0.4 into, in acidic medium, it is 5. 5 into we don't know, x is equal to m2. M2 we know, which is 0.05. Now, we know that Fe2 plus will become Fe3 plus. So, valency factor is 1 into V2 is given, which is 50. Can't you find x? Can't you find x, guys? Tell me. Right? You can find x. So what is x? X is equal to, tell me, 2.5 divided by 2. Okay? Right? Which is 1.25. Milliliter. Got it? Got the concept, guys, everyone? Got the concept? Yes or no? Just raise your hand. If everyone got the concept, just raise your hand. Okay, very good. Very good, everyone. Okay, now I will give you one example in which you can use both mole concept as well as equivalent concept. Okay, right? So let's see one question. So you should be aware that when to use which concept, right? You can use both concept, okay, but you should be aware that if the reaction balanced, then only you should use mole concept, okay? Okay, let's write down the formula, guys. Sorry, let's write the question, my bad. So the question is, how many millimoles, milliliter, how many milliliter of 0.02 molar KMnO4, okay, solution is required right, to titrate 25 milliliter of 0.2 molar FeNO3 whole twice. Okay, now tell me guys, using equivalent method you can solve, right? Try to solve this. Try to solve this guys. So first try to solve by equivalent method. Equivalent method. Okay. I guess someone could have solved, right? Please tell me the answer. This is same as the last one. This is exactly same as the last one. Fe2 plus, it is exactly same, right? N1V1 is equal to N2V2, or M1V1 N1 is equal to M2V2 N2, right? M1 is given as 0.02 into V1, we don't know, X, N1, since it's in, so I will consider it as an acidic medium, okay, right? I'll consider it in acidic medium. If nothing is given, then acidic medium, okay. 5. M2 is given as 0.2, V2 25, N2. Fe2 plus is converting into Fe3 plus because it can have only one option. So 1, right? Tell me, got it? Right? Right, everyone? So X, you can calculate X is equal to what? It is 5 divided by 0.1. So it is 50 milliliter. 50 milliliter, na, Anisha? 50 milliliter, right? Okay. Now tell me, this is easy. This is easy. Now, second is mole concept. So we know the reaction. Reaction is this. I'll just write the elements which is oxidized and reduced. Okay. So it is MnO4 minus plus Fe2 plus, right? It will convert into Mn2 plus Fe3 plus. So we will use oxidation number method. We will use oxidation number method. 1 electron lost. Okay. 5 electron gained. So it should be multiplied by 5. 5, right? Now it is balanced. We don't have to worry about hydrogen, oxygen. Okay, now it is balanced. So we will use what? We will use mole concept, right? Which is moles of KMnO4 divided by 1 is equal to moles of FeNO3 whole twice divided by 5. Got it? Now, now tell me, don't you think that this is the same equation? Tell me, guys, don't you think? I hope all of you are getting now. So it is M1 V1 by C N2, which is this, is equal to M2 V2 by N1, which is 5. Don't you think that this is the same equation? Now I hope all of you are getting my point. Why both are actually same, right? It's just that you have to do balancing. Okay, now everyone got the concept? Guys, tell me, raise your hand. Everyone got the concept? Basics of titration? Okay, let's solve one more simple problem, right? One more simple problem. So I'm just solving simple problems so that you can get the idea. Okay, so the question is 20 milliliter of, and see, in JEE mains, NEET, these kind of questions will be asked, right? H2O2 after acidified with H2SO4, dilute H2SO4. So dilute H2SO4. Okay, require 30 milliliter of 1 by 12 N or N by 12. This is normality, right? Same as molarity. This is normality. KMnO4. Okay, for completion. Right, or complete oxidation. Completion means complete oxidation. This is oxidizing agent, na? Right? Okay, got it? So find strength of H2O2. Okay. Now strength is actually your concentration, right? So here it is normality. Tell me, guys, solve. Everyone, please try to solve. Simple formula putting getting, guys. Yes, Nishita, very good, correct. So see, in this case, normality is given, right? You just have to use N1V1 is equal to N2V2. Nothing more than that, right? So what is N1? N1 is, tell me, 1 by 2 into 30 is equal to, this we know 2x into 20, right? So x is equal to what? 30 by, so this is 1, I have written 1 by 2 kya? Sorry, it was 1 by 12. So according to 1 by 2, the answer would have been different, right? Right, Nishita? According to, if it's 1 by 2, the answer would have been 2 into 20, which is 3 by 4. Okay? Did I say 1 by 12? Because if it is 1, see, according to 1 by 2, answer is 3 by 4. Okay? Right? I've written 1 by 2. I think I spoke 1 by 12, right? Anyways, all of you got the answer, right? All of you understood the concept. It was basic formula putting getting. So shall we solve one difficult problem, comparatively difficult problem? Ready? Ready, guys? Okay. So I guess all of you can understand these concepts, formula putting getting. Okay. So yes, it's not that difficult. You just have to understand. Okay. Right? Not everything is given straightforward. So the question is 1.2 gram of, or 1.2 gram mixture of, right? Mixture of Na2CO3 and Na2CO3 and K2CO3 was dissolved in water. Dissolved in water, right? As I'm writing, try to understand the problem, right? As I'm writing, try to understand this problem. Okay, so we have a mixture, right? Mixture of Na2CO3 and K2CO3, which is dissolved in water to form 100 milliliter of solution. So the volume solution is 100 milliliter. Okay, 20 milliliter of this solution, 20 milliliter of this solution require 40 milliliter of 0.1 normality HCl. Okay, for complete neutralization. For complete neutralization. Okay, right? You have to calculate weight of weight of Na2CO3, weight of Na2CO3. Okay, this is first part. Second part, if another 20 milliliter, if another 20 milliliter of solution is treated with excess BaCl2. BaCl2. What will be the weight of precipitate? What will be the weight of precipitate? Okay. Step by step, guys, step by step, right? It is just like solving equations. It is just like solving equations. So I'll just give you a hint, right? So this 1.2 gram is a mixture of this and this, right? Suppose this is X, right? Na2CO3 is X. So what will be the weight of K2CO3? Tell me, what will be the weight of K2CO3? Right? 1.2 minus X, as simple as that, right? Molecular weight of Na2CO3 is what? Right? Molecular weight of Na2CO3 you can calculate, which is molecular weight of Na into 2, right? Into molecular weight of CO3. So molecular weight of Na2CO3 will be 106. Calculate, will be 106, and molecular weight of K2CO3 will be 138. Right, everyone? Think about it. I'm giving you 1 minute. Sorry, I'm giving you 5 minutes. Try to think, okay? Okay, guys, just try to understand what is happening. Okay, just try to understand what is happening first. Now, if you see, if you just break down this problem, okay, the first part, just try to solve first part first. 1.2 grams of Na2CO3 and K2CO3, right? Both are your salts, right? Basic salts. They are reacted with acid, right? Okay. Now, don't you think that both will react with acid? Yes or no? Yes or no? Right? So I can say that the amount of H plus required to neutralize both Na2CO3 and K2CO3 should be equal to amount of H plus from this HCl taken. Yes or no? Tell me, guys. Yes, right? So I can say this. Okay, let's break down this topic, right? So we have a neutralization reaction, and for neutralization reaction, okay, I'm having HCl. So moles of HCl taken, okay, right? Or instead of writing moles, since it is better to write equivalent concept, I can write like milli-equivalent of HCl should be equal to milli-equivalent of Na2CO3 plus milli-equivalent of K2CO3. Yes or no? Tell me, guys, yes or no? Got it? Okay, right? Now, milliequivalent of HCl. What is milliequivalent of HCl? Tell me, milliequivalent of HCl is normality N1 into V1, which is N into V. Milliequivalent of this is, again, normality is not given, number of moles you can find. So we'll go with molarity into V into N. So since volume will be same 20 milliliter now for both, so I'll just write V, and this is N1 plus this is M1, M2 into V, because volume is same 20 milliliter into N2. Okay, now everyone is satisfied with this? Tell me, everyone is agree? Sorry, everyone agreeing on this? Anyone have any issue in this? Tell me yes or no. Okay, now let's see this. Yes. Okay, now N1 is given. What is N1? N1 is already given, which is 0.1. See, N1 is 0.1 given. So I'll write 0.1. 0.1 into V1 is 40 milliliter given, 40 milliliter. 40 milliliter. Okay, right? Anything else is given? Okay, is equal to M1. M1 is, we don't know M. We don't know number of moles. So number of moles is X by 106. But molarity is number of moles per volume. So I'll just take it as 1 liter. I'll take it as 1 liter, right? 1 liter. That's the definition, na? Per liter, right? This is 1 liter into. So this is whole into, right? This is whole. This divide will go in the numerator. Volume, which is 20 milliliter, right? 20 milliliter, 20 into this. Tell me, what is this? This is 2, because Na2CO3 will give 2 electrons. So Valence factor is 2. Plus this is 1.2 minus X by 138 number of moles, thereby volume, again 1000, right? Right? Into 20 volume into 2. Okay? Okay, guys, got it? Now, if you solve this, we will get what? 40 into 0.1, okay, is equal to X, and this 2020 we can take and we can just do it here, 20 into 2, and this will be X into 1000 by 106 plus 1.2 minus X into 1000 by 136, 36 or something else. Sorry, 138. No, it was 138. My bad, 138. Agree? Got this? Now, there's a very small mistake. What is that mistake? Tell me. There's a very small mistake. That's a mistake. Wes, that's a mistake. Okay. So the mistake here is, yes. Right? So this is mistake. Okay. Yes. There's one more mistake, which is see the solution or see the question, right? What is the total volume of solution? Tell me, what is the total volume of solution? 100, right? So when you talk about molarity, for molarity, the volume should be 100, yes or no? Tell me, for calculation of molarity, this should be 100, okay? This should be 100 and this should be 100. But since this we have taken in, since we have this taken in milliliter, right? We should multiply by 1000. Yes or no? We should multiply by 1000 because this should be in liter, right? But if you're not taking in liter, we should divide by 1000 now. So here it will multiply by 1000. Got it, everyone? Tell me, got it? Yes or no? Yes or no? Tell me. Because this is solution, first line. Solution is of 100 milliliter. So molarity of Na2CO3 is number of moles, which is X by 106 by volume. Volume is 100 by 1000. Okay, so it will come to X by 106 into 100 into 1000. Got it, everyone? Tell me, got it? So into 100, into 100. Okay, cancel, cancel. So if you solve this, you will get something like this. 40, 40 cancel. This, right, 10 will be divided over here. So 0.1, okay, 0.1. Okay, Abhiram, wait. Okay, so 0.1 is equal to x, 10x by 106 plus 1.2 minus x into 10 by 138. So 10, if you 10 multiply this 10 here, so it will become 100. So it will be what? 10.6. Wait. I'll just try to simplify the calculation. Okay. So it will be 0.01 is equal to x by 106 plus 1.2 minus x by 38. Take 100 this side. Okay. So you will get x by 10.6 is equal to x minus 1.2 by 13.8. Calculate, solve. 13.8x is equal to 10.6x minus 10.6 into 1.2, right? So it will become what? Tell me. 12.72, right? Got it? Okay, so there's a small mistake I did somewhere, I guess. Let me check. Right, so this is 1 minus. Okay, my bad. 1 minus this, right? Right, guys? So you have to solve this. If you solve, you will get the value of x. Okay, Abhiram, are you getting? Okay, so you just have to solve for x. Okay, just have to solve for x. So I'll solve anyways. X by 10.6 is equal to 13.8 minus x minus 1.2 plus 1.2, sorry, divided by 13.8. Okay, so obviously it's a calculation. Okay, it is a calculation. So x by 10.6 is equal to, this is 15 minus x by 13.8. So after solving, we will get 13.8x plus 10.6x is equal to 15 into 10.6, right? So x will be 15 into 10.6 divided by 25.4. Right, everyone? So you have to solve for this. So 159 by 25.4. There's some mistake I did again, I guess. Yeah. That's why there's some mistake I did again, I guess. I don't know what is happening today. Okay, guys. So this is the calculation. This is the answer. So x is 0.596. So the next is 1.2 minus x. So you can find it. So this was the first part. Okay, this was the first part. Second part. Okay, if the same 20 milliliter is treated with excess of BaCl2. Now, if BaCl2 is treated with this, what it will be forming? Tell me. If BaCl2 reacts with Na2CO3 plus K2CO3, it will form what? Obviously, it will form Ba2CO3. Sorry, BaCO3, not Ba2, BaCO3. BaCO3, yes or no? So this is the precipitate, right? This is the precipitate. Okay, NaCl, NaCl and KCl we will remove, right? Okay. So using this, can I say that same thing, same concept, milli equivalent of Na2CO3 plus K2CO3, same thing, should be equal to milli equivalent of BaCO3, right, everyone? Tell me yes. Okay, right? Right, guys? And this should be equal to milli equivalent of HCl, because see, the volume is taken as same, right? So I'm just equating this equation. This is equation A. This is equation A. Wait. This is equation A. Wait. Yeah. Equation A, and this is equation B. Equation B. So I'm just equating equation A and equation B. Question is this, right? We are solving this question for half an hour. Now you can just watch video once again, right? At the last, because we don't have much time. So you can just equate it. So milli equivalent of BaCO3. I'll just explain at the last question, okay? Now it is already given, right? It is already given, which is 0.1 into 40. Okay, so we know that it is weight by equivalent weight. Milli equivalent is weight by equivalent weight, right? Is equal to 0.1 into 40 into 1000, by the way, right? It is normality to this one. M1, V1, M1 is equal to 0.1 into 40. M1 is given weight by molecular weight 197 into 2 into 1000 is equal to 40 into 0.1. So you can find W. Okay, W is equal to 0.4 almost grams. Okay, so Karishma, the question was 1.2 gram of Na2CO3 and K2CO3 was dissolved in water to form 100 milliliter, right? So we have this Na2CO3 and K2CO3, right? The weight is 1.2 gram of mixture, and they are mixed to form, okay, they're mixed to form a solution, and the weight of solution is 100 milliliter, okay, right? Now, after mixing, right, it's like this, you mix a syrup, right? You mix a syrup, and then you take 1 spoon of syrup and make your lemonade, right? That's what we do now. In the same way, they make a solution in which they mixed Na2CO3 and K2CO3 in 100 milliliters. So that's different solution. Now, from that solution, they are taking 20 milliliter, right? 20 milliliter, and this 20 milliliter require 40 milliliter of 0.1 normality of HCl. Okay, this is first part. Then we have to calculate the amount of Na2CO3 and K2CO3. Okay, okay, Karishma, right, guys? Okay, so we will have one more class of titration. I'll tell you the timings. It will be extra class. Okay.